Okay, putting the camera back on for a second. By the way, we're working on this packet called complex roots packet, so if you are watching this on video, hopefully you picked this up from me at lunch and now you're doing it. Number one, I'm just gonna talk about number one for a minute, even though maybe everyone already figured it out. I can't remember if it's if this is obvious to you or not. But you have all this information, right? And somehow I have to figure out what the rule for this polynomial is. Well, how do you actually do this? Here's what I know. I know that f of 4 minus I is 0 now by the rule that complex roots come in conjugate pairs. And since I told you in the problem that the coefficients were real, that means that f of 4 plus I is also a root. And since 5 plus 2i is a root, that means that f of 5 minus 2i is also a root. And so what I have is, it's a 5th degree polynomial, and it has 5 roots, so we're pretty much good to go. Therefore, using the factor theorem, I can write out what this polynomial actually looks like. Well, seeing as 4 minus I is a root, then that means that x minus 4 minus I must be a factor. And if 5 plus 2i is a root, well actually, let's do it in order. If 4 plus I is a root, then if 4 plus I is a root, then x minus 4 plus I is a factor, and just keep going and going with this, right? If 5 plus 2i is a root, then x minus 5 plus 2i is a factor, and x minus 5 minus 2i. And then finally, 2 is a root, so x minus 2 is a factor. Can someone peek to make sure we're in frame? And then there's one more thing. Now, Kim, how many 5th degree polynomials are there with precisely these 5 roots? Infinite number of them, because there might be some leading coefficient which is instructions, blah, 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 blah. So I have to stick that in right there. All right, and now it's just a matter of, and basically finding A is the only thing we have left to do to be done with the problem. And that is the reason why I gave you this extra little piece of information, which enables us to, George, you cool? Yeah. Yeah, did we do a problem like this already?
Yeah.
Yeah.
Okay, so maybe I'll go even faster. And now, what's the smart thing to do here? Yeah, you do a move the parentheses move, right? You just rewrite x minus 4 minus I as x minus 4 plus I, and you rewrite this as x minus 4 minus I, x minus 5 minus 2I, and x minus 5 plus 2I. That move enables you to then multiply these things out really easily, because this times this now is like the difference of squares and their conjugates, so it all works out. No, can you good?
Yep.
Yeah, so this becomes A, and then can I skip some steps here? This would just be x squared minus 8x plus 16 minus I squared, but then that's just a plus number, so this becomes plus 17. Yeah, yeah? Yeah, yeah. And then over here I have x squared minus 10x plus 25, but then minus 4i squared, which is really a plus another 4, so that's plus 29 times x minus 2. I really just did all of that just so that it would be easier for me to plug in 1. I guess if I was some kind of crazy person, I could just plug in 1 here, but I don't recommend it. It's possible, it's doable, it's just harder. But now that I got down this far, I think I'm ready to just plug in 1, and if I plug in 1, I get A times, I guess that's 10, and then here I get 30, that's 20, and then when I plug in 1 here, I get negative 1, and all of that is supposed to be 400 according to that initial condition. So now I have a little equation which says negative 200a is 400. You guys following this? So yes, good. So a is negative 2. So using this sequence of steps, I have now determined that the function actually looks like negative 2 x squared minus 8x plus 17 times x squared minus 10x plus 29 times x minus 2. And when I said it's not necessary to multiply it out, all I mean is that you can just leave it like that. Cool? Okay, good, that's all. Raise your hand if you already knew exactly what to do and you already even did it and when you did it right. Okay. Raise your hand if this helped, this little 5-minute thing. No one? Yikes. Sorry, people in the video. Okay, keep working then. Gotta know when to strategically ignore the teacher. What did you do here? You have no work shown, you have nothing on your paper, you're writing in font size 50, and then you have the answer and nothing. What are you doing? No, that's Not acceptable. I have no idea how you got this. How did you possibly get -2? Do the entire problem in your head.
Well, I got the thing, and then I multiplied it out in my head.
Is there a fast way to do the third?
It's a really, really bad idea.
Negative b over a plus some roots and all those kinds of things.
Okay, we'll just leave the video playing. Those of you at home watching, do your complex roots packet.
Yeah.
Didn't I tell you guys as a class rule that you can't work on both sides of a trig identity? I said so, right?
Yeah.
Yeah. Guam. That's right.
Cameron.
So,
Yeah, I know. Oh yeah, thanks for reminding me.
okay.
You should take out all the points for
All the points. No work on both sides.
Because you know that
what?
it's only 1 degree, so you need over 3 degrees.
For free, saying it to the entire camera.
Okay.
Wait, here. Okay.
I got it. Thanks.
Two of them.
So easy.
Yeah. Yeah.
Yes.
That's
I just
why
said that.
I'm so bad. I'm not stable.
Actually, only grading the people's quizzes are actually here.
Why are you trying now? Normally. It's already been discovered by somebody else. Yeah, you probably. You have to know what's that.
This is 2.
But nobody wants to do it.
God, Jason, I just can't read anything you're doing. Why do we use pencil in math class, Jason?
What?
Why do we use pencil in math class? Not a rhetorical question.
So we can erase it.
So we can erase. Not so we can just like scribble incoherently all over the paper and just like crazed madman journal style like nonsensical scribblings. I cannot read anything you're doing. Come over here so I can scream at you closely. It's a trig identity, right? Which means it's a proof, which means it has to go in a step-by-step logical fashion that's like perfectly clear to the eye. I have no idea. No. Where? What? I don't even know what you're doing. Where are you beginning? Which side are you even starting with? I can't even, literally can't even tell. Okay, so how about, am I supposed to just know that? It's a trig identity, right? Here's the following step. Everyone, are you listening as I scream at Jason? Here's the following step would receive no points, just writing the trig identity. Like, oh yeah, I just did it in my head. Do you see how that's not acceptable? Yeah, because it's not acceptable, because I'm telling you it's true. So what I want to see is your demonstration that it is true. So you're not allowed to simply like skip 7 steps, because I have to be able to follow it. It has to be step-by-step, follow, clear proof. I have no idea what's going on. What's going on? You start with this side, and then what did you do? You just like expanded it all out and also split it up all in one step. And then you multiply by this, cosine squared.
Doesn't matter, some of it's with the addition of.
Don't do this again. Good, Daniel, what's up?
Oh, it's just the camera's still recording.
Oh, the camera's still recording? Yeah, I didn't say anything that terrible, right? Yeah, it's still, it was just recorded by Daniel, or my Jason who lectured. Oh, God. Alright, how's this going?
Is addition considered algebra?
Is addition considered algebra? Yeah. By algebra I mean you can use the sum and factor roots formula. Yeah, good.
You can just use addition.
Good. And then the rest of this packet's like kind of boring, right? It's more or less like the same thing over and over again.
Number 6 is actually a bit fun.
Number 6 is fun?
We use synthetic quadratic division.
Ooh, interesting.
Although it's
Yeah, for number 6 you have 2 options essentially. What are the 2 options for? Alright, you guys on number 6 yet?
Okay, now,
Oh man. Sahil. Guess what's a triple? 7, 24, 25. That's a triple. You heard of that before?
I think so.
Yeah. It's a triple. Good. Glad we had the conversation.
11 times 5 is 55. Quadratic synthetic division is fun. Does it work? Yes, it actually works. I don't even see the process. How does this work? Wait. You multiply by 7 and add 2. Where do you get the 6 from? Oh, yeah. See, you multiply by 2 and you also multiply by 5. And then you take this and this.
wait, is that synthetic quadratic division?
Yes,
Oh,
it is
okay.
synthetic quadratic division.
What happened if the leading portion doesn't exist?
The leading coefficient is sort of 1.
Are you defining it to be so?
Synthetic quadratic.
What's that mean?
And also, you didn't need just use 7 quadratic roots. Let's see, f of 1 minus 2i is 0. And that means, yeah, it's like a fractional. It's like,
What just
I
happened?
didn't say not use
I guess 7 is-
but like,
I don't know.
Why did they just show batteries?
hey, how do you do the Stella 2D over 2 opera?
No, it's easy. You just copy these of Clarence and you got this one.
Oh man, Misha.
I didn't get, no, but when I did it, it said fail, but the value becomes 0.
I always have to give you one back.
Maybe it's spiral.
I always have a line.
For the 1 year, 2D.
1 week I got a spiral.
I'm gonna dance with it.
Got a line.
You probably messed up all the right negatives there.
I put question.
I don't know.
What's
No, it's not properly.
So that's
It becomes 51. Negative 4. If you plug in this.
That's not the answer. It's only 2 things.
No. Oh, it's just, oh, figure out what A is. Come on.
I don't know what to do is.
What if it is 51 times
What's 51 plus? That's 17 times 3. A, that's negative 2 then.
2? No.
I don't know.
It's negative and this is negative.
This is negative.
This 350 negative. 351 A is equal to negative 102. Uh-oh. So synthetic cubic derivative of work is
You should do 4 distributions.
just it's giving me a bad Oh. Right. Okay, Dan, so look at this amazing system with this. Much easier than it is in that quadratic English.
Alright, so this is going well?
Yeah.
Okay, cool. Let's do something else. Algebra packet 6. How
Third one was the widget one.
is that
I
going?
got
That's
11.
625. What would
X equals 625.
No, the price was 625. I got $4.
$625?
No, Elsie had
$6.25.
exactly. Oh my god.
I got $4. Congratulations, that's way too little.
That's lower than $5.
Yeah.
How
No,
does that make
it's
sense?
possible, it's go lower than $5.
But you
but it
can.
doesn't work.
No.
Number
You
18
can't sell
could
more.
have been expressed as a diagram.
Why doesn't
It
he?
was
I got
kind of cool. I just like stopped
Yeah.
doing work when I
65
realized that
widgets
there's
still
easy
is-
ways.
That you can just use common sense?
Yeah.
Daniel,
Um,
the thing is, 80 minus 5x times 5 plus 0.25x
Okay,
minus
so let's talk about algebra packet 6. Let's see, well, just call out Theo's answers, I'm sure they're all correct.
Actually, they're probably not.
Wait, what?
We'll call out my answers, I'm sure they're all correct. Somewhere. Yeah.
System of the class.
I'm right, Daniel.
So.
I can't understand your work.
What? How can you not? That is literally a linear progression.
Number 1, I got 3 halves.
Yeah.
Number 2, I got 6 and negative 1.
What?
But
Yeah, I did too.
Yeah, that's it as well.
Number 3, I got negative 9, 3, and negative 3 plus or minus 2 root 3.
Yeah.
Good. All of these involve turning it via creative methods into something of quadratic type. Is that how you guys did it?
Yeah.
Good.
2, 3.
Stop me if you want me to go over a problem. Number 4 is pretty tricky. I got negative 6/5 and 1.
Yeah.
Okay. Number 5, I got negative 1 and negative 4.
Yeah.
I can go over any of these if you want. And okay, so George, here is essentially the issue. The issue was here's the function. This function is x squared minus 1 minus 4x minus 5. I want to know when it's going to have a double root. Well, first I'll put this in a kind of a standard form. So this is mx squared minus 4x, and then the constant term, I guess, is like negative 5 minus m, right? Say right.
Right.
Is that right? Yeah. So, yeah. So I want to know when there's going to be a double root. So there's going to be a double root. Well, basically, only if the cool way to do this is there'll be a double root if the discriminant is 0, right? That's actually the cool way of doing it. So if I have some quadratic ax squared plus bx plus c, then the only way for there to be a double root is if it's a perfect square. So if it's like a x minus, what is that, like b over 2a squared plus like other stuff. No. plus 0, I guess, right? Actually, let's do this properly. Plus, this is like 4ac minus b squared over 4a squared. I think, did we do this out? I think we did this out, right? We showed that any quadratic whatsoever is expressible via completing the square and transform to be like this, right? So the only way for this quadratic to have a double root, one way of thinking about it is that it's just sitting right there on the x-axis, which is another way of saying that this leftover thing is 0. Probably the simpler way to do it is just to think of the quadratic formula. The quadratic formula says that the solutions are negative b plus or minus root b squared minus 4ac all over 2a, and the only way for there to be a single number which is coming up twice is if the discriminant just dies. So how I did this problem is to say there's a double root if and only if basically the discriminant is 0. So b squared, which is 16, minus 4a, which is m, and c, which is that. I'll just make that a plus, and I'll make this m plus 5. And this must be 0, and when you do that all out, you get my answer. Cool?
Cool.
Okay, how about the next problem? There's actually, these problems are getting pretty hard. That algebra packet 6 was actually pretty hard. I thought it was the hardest one yet of the algebra packets. Do you want to go over anything on page 3?
Wait, what's the answer to number 6?
The answer to number 6 is 10 and 12.
Yeah.
Oh, okay.
10 and 12.
How do you do it?
Wait,
6?
6 I got 8.
You just like,
This is actually an easier version of a problem I gave you like way back in September.
sphere one.
Yeah, the sphere one. Basically, it's just an application of difference of cubes, right? You have two numbers. The difference of the cubes is 728, and the difference of the numbers is 2. So you started.
Yeah, I know.
I don't know, something went wrong. Come on. I think it's just algebra. That's the whole point of algebra, to get good at algebra. Page 3 was interesting. Page 3, Sal, this is the Pythagorean triple thing I was just talking about, right? Yeah. So what were we supposed to do? We were supposed to, I think we had an advisory today too. All right, we gotta go super fast. What were we supposed to do here? I don't know, what were we supposed to do here? Find the length of the hypotenuse of a rectangle with 2 sides up. Oh, so you just do it, right? Do we need to go over this? I don't know. It's pretty hard. Number 7, I thought. How'd you guys do it?
Number 7.
Just like took care of it? Good job.
4 and 7.
Put everything together.
What did you get for this one?
Get the way in.
The minus 4 and the minus 2?
This one's doing right.
Yeah.
I just did this.
Yeah, cool.
So you didn't do anything.
So the way I did this for part 7, so we have two side lengths, 2n minus 1, and the other leg is 1/2 2n minus 1 squared minus 1, like that, right? And then what I want to show is that the hypotenuse, to find the length of the hypotenuse. So I end up with this like just giant radical, right? Which is just like terrible. It's like 2n minus 1 squared plus, and then it's like the square of 1/2 2n minus 1 squared minus 1, you know, squared or something like that. And I want to try to make this pretty. So how do I do this? I guess I just do it, right? So this is 2n minus 1 squared, and then this is like, well, this is like 2n minus 1 to the 4th minus 2 times 2n minus 1 squared, and then just like plus 1. But all of that's like over 4, right? So that's over 4. So let's make this over 4 also. So I do a 4 like this. Is that looking okay? What's up? Is there a better way?
It also simplifies in a beautiful way if you just sub like x in for
2n minus 1. Yeah, that's what I did on my paper, but I'm trying to be cool here and not do that. But yeah, I agree. It's prettier if you just think of that as, if you just make that a single variable. But anyway, I'm with you, George. But anyway, now what we see what's going on here is there are 4 of these 2n minus 1 squares. Over here there are 2 of them, right? So they kind of cancel each other out. So I end up with there's a 4 in the bottom, so I'll take that out with a 1/2. And then otherwise, there is basically what I have is 2n minus 1 to the fourth plus 2n minus 1 squared plus 1. That minus became a plus because they added the 4 guys over. And then that conveniently is also a perfect square, right? So this is 1/2 root, well, it's just like 2n minus 1, what is that? Squared plus 1, right?
No.
Yeah. Right? Yeah. Squared plus 1.
It shouldn't, what? Shouldn't that be all that squared?
Yeah, well, that's good.
Oh yeah, and then squared. Right, and then squared.
Yeah.
And then you take the square root. So it becomes 1/2, well, it just becomes 1/2 2n minus 1 squared plus 1. Alright, so the grand conclusion of all this, are you guys tilting the camera? I feel like you're not. The grand conclusion of all this is that we have just proven, oh, and then I said argue by parity. Did I say that somewhere? Argue that if n is an integer, all of these side lengths are integers. Okay, let's just walk through this argument really quick. That's obviously an integer because duh. This is an integer because odd squared is odd, and then minus 1 will be even, so divided by 2 will be an integer. Yeah?
Yeah.
Down here, this is odd squared, so that's odd plus 1 is even, divided by 2 will be an integer. Alright, so thus, I have just proved that for any integer n, the following is a right triangle. 2n minus 1, 1/2 2n minus 1 squared minus 1, and 1/2 2n minus 1 squared plus 1. In other words, I can make a Pythagorean triple out of any odd number whatsoever. So let's just like take n equals, I think I better start with like 2. So if n is 2, then this says that I have a triple. And that triple is 3, the second odd number. And then down here it's like 3 squared minus 1/2 of that.
4.
4. And then 3 squared minus, 3 squared plus 1/2 of that. 5. And in fact, these two numbers are going to be almost half of the square of that odd number, right? Off by 1, right? In either direction. Okay, and so then when n equals 3, we get, now it's the third odd number.
12, 13.
This is 5, right? And then basically this says you square that number, add 1, take half of that. So basically what we're doing is we're taking the two numbers which add up to be the square of that number, 12, 13.
40, 41.
So this is just, what we have is an infinite number of Pythagorean triples, all starting with any particular odd number. If I set n equal to 4, then I get 7, and these are just 24, 25, right? It's the two numbers which add up to, yeah. Have you guys seen this before? Have we talked about this before?
Yeah.
We did? Okay, good. So yeah, you just have like a bunch of these, right? 9,
40.
and then just like 40, 41. So that's like maybe like relevant to this unit. And then, yeah, in the first part of 7, we also proved that 2n, n squared minus 1, and n squared plus 1 are also form a triple, which means that there's actually a triple given any number whatsoever, right? Because this is any even number and any odd number. So that's kind of the cool thing about that bit. All right, should we do the widget problem? I thought the widget problem was kind of interesting.
What about
Was
there?
it 625? Yes, 625. Yeah, well, you did 450. Well, that's because I forgot
How
that
does that
this
differ?
Okay, widget problem. There is a
How can you
widget.
sell negative?
There is a widget merchant.
You can't sell
And the widget merchant found that when he prices widgets at $5 each, he can sell 80 per day. When he prices widgets at $5.25, he can sell 75. And each time that he increases the price of a widget by 25 cents, he sells 5 fewer widgets per day. If a widget costs, so hard. Okay, maybe not so hard. I don't know. So let's just like read this. Let's see what we see. Well, when it's $5, we can sell 80 widgets per day. When we price widgets at $5.25, we can sell 75 widgets per day, et cetera, et cetera. Every time he increases the price of a widget, he sells 5 fewer widgets. Okay, so I thought of this as 5 plus, and then I said, all right, let's let x represent the number of quarter price increases. price increases. This is how I thought to do it. And if I let x, if I define x to be the number of quarter price increases, then basically what I'm saying is every time I add a quarter to the price over $5, then I'm going to sell 5 fewer widgets than 80. Basically, this is the reading comprehension part of the problem. Okay, so if that's true, then what do I have to do? Also the widget costs $3.50 to produce. So I have to like factor that in too. Okay, so what is the price? What's the price of a widget? Wait, hold on. What did I say?
Create a function for the number of widgets to sell in a day based on the price.
Yeah.
Yeah. No, just.
No, I
just
think I
make
want.
a function of the profit.
Yeah.
Yeah, but then you do that
Make
based
a function
on.
of the profit. Like
do
you
that
just do
based
the
on the
number you
number
sell.
you sell.
Okay, yeah, sure. So yeah, so there's a general idea here, right, which is profit. Profit is like revenue minus expenses or something like that. Revenue is like the money that you take in at the end of the day, and expenses are like expenses. So the profit, I guess, the profit per day is like the revenue minus expenses, you know, like per day or whatever. Something like that. Is that kind of what I mean? Yeah, I think so. So what are my, what is my profit? I want to make a profit function, which is a function of the number of quarter price increases. Well, the revenue is the total number of widgets which I sell per day, which is 80 minus 5x, times the amount of money I make. No, I think I screwed that up. Oh yeah. The number of widgets I sell per day times the price I get per widget, which is 5 plus 0.25x, and then minus, or maybe it's better to just do it as like the per if I just do it per widget, right? If I take in 5 plus 0.25 per widget, x, and then I just like subtract out the 350. So this expression represents my like profit per widget, right? Yeah, profit per widget times number of widgets per day. That's going to give me my profit per day. Yeah. So now this is just a quadratic. I just have to like make it pretty because it's pretty disgusting at the moment. Let's see. This is like this is like x over 4 plus 3/2 times like I'll pull out -5, and then it's like x minus 16 or something like that, right? So actually, making this maximally pretty, it's like -5/4 x minus 6 plus 6 x minus 16. Do you agree? That is my quadratic function which represents profit. Okay, what does it look like? It looks like this. There's a root over here at -6, and there's a root over here at 16. This is actually a very interesting problem because you can like, okay, well it's an upside down quadratic.